Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram College, Mysuru. Two-dimensional array is a collection of elements. Of each element is identified by pair of subscription, searching, sorting. So for 3 cross 3 matrix. Why it is 3 cross 3? We will get 3 columns and 3 rows in 3 cross 3 matrix. So insertion and deletion is very difficult to implement in array data and we can manipulate it easier. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed about searching operation on one-dimensional array. What do you mean by searching? Searching means searching an element from the array. Searching means searching an element from the array. We have used two types of searching method, that is linear search and binary search. Linear search and binary search. What do you mean by linear search? This is the simplest searching method in which each element of the array is searched one by one. That means from beginning till end of the array we can search the element in linear search. We have discussed about the algorithms and one example problem also have given in linear search. And next one have discussed binary search. So what do you mean by binary search? Binary search means when the elements of the array are in sorted order. When the elements of the array are in sorted order like 5, 6, 7, 8, 9, 10. When the elements of the array are in sorted order, we can use the mid is equal to int of b plus e by 2. Using this midpoint, we can find the particular location of the element in binary search. In this sorted list of the element, we can search an element in a binary search using mid value. So, in my last session, I have discussed linear search algorithm and one example problem and binary search example and algorithm. So, today I am going to discuss about the topic called sorting the elements in an array. Sorting means arrangement of elements of the array in some order. Arrangement of elements in some proper order, either in ascending order or in descending order. Sorting means arrangement of elements in some proper order. There are different sorting methods like bubble sort, insertion sort, selection sort, quick sort, heap sort, etc. But in your syllabus, we are going to study only the insertion sort. Very important question. Explain the insertion sort in detail. 5 marks question. What do you mean by insertion sort? Just take a list of elements. Just take any list of the elements, example 65, 43, 28, 70 and 50. Just take a list of the elements which is unsorted. This is not in a sorted order, right? This is not in a sorted order. We have to arrange it in a sorted order. Clear? In insertion sort, just take a list of the elements. In each iteration, you just compare the elements from one to another. Just compare the elements from one to another, then arrange it in a proper order. That is called as insertion sort. In insertion sort, the first element of the array is assumed to be the correct position. The first element of the array is assumed to be the correct position and the next element is called as the key element. So, first element is assumed to be the correct position and the second element is called as the key element and compared with the elements before the key element and is inserted in its correct position. You just take the key elements compared with any other elements and arrange it in a proper order. You will get the final sorted list. So this is called as insertion sort. I will explain you with an example. So here we have 5 elements list. This is not in a sorted order, right? We have 70, 30, 40, 10 and 80. This is called as A, is name of the array, and the index values starts from 0 to n minus 1, that is A of 0, A of 1, A of 2, A of 3 and A of 4. We have 5 list of elements. This is not in a sorted order. We have to arrange it in a sorted order. Here we have to compare all the elements one by one. When index value is equal to 1, then I will take one more variable called j and copy this value to the j is equal to 1. So compare this A of 1 means 30 to first element called 70. So 30 is less than 70. So you can swap this elements, 2 elements you can swap. So the array will be look like this. This is first iteration. In the first iteration I have compared these 2 elements. 30 is less than 70. So I swap these 2 elements. So array will be 30, 70, 40, 10 and 80. So first iteration is completed. And in second iteration, when I is equal to 2, so j is equal to 2. Copy these 2 variables and you just compare these 2 variables. Compare these 2 elements 40 with 70. So 70 is greater than 40. So I can interchange these 2 elements. So your array will be 30, 40, 70, 10 and 80. And again compare these 2 elements, that is 30 with 40. Is there any changes? No. 30 is less than 40. So there is no swapping happened. So 30, 40, 70, 10 and 80. This is the third iteration. So this is in a sorted order. 30 and 40 is in sorted order. This is in unsorted order. 30, 40, 70, 10 and 80. In the fourth iteration, I will compare this 70 with 10. 70 and 10. This is not in a sorted order. I will compare this 70 with 10. So what will happen? 30, 40, 10. Swap these 2 elements. You will get 10 and 70 and 80. In the fourth iteration, you just swap these 2 values 10 and 70. You will get this array. And in next position, you just compare these 2 elements because 10 is lesser than 40. So 40 is greater than 30. You just swap these 2 elements. It will be 70 and 80. Just swap this 10 and 40. You will get 30, 10, 40, 70 and 80. And in next iteration, you just swap these 2 elements because 10 is lesser than 30. So I will swap these 2 values 10, 30, 40 and 70, 80. So here it's in sorted order, right? And again in the next iteration, you just compare these 2 elements 70 with 80. Is there any changes? No changes will happen. So because 70 is less than 80, 70 is less than 80, there is no swapping happen. So you can write 70 and 80. And you can compare this 80 with other elements like 40, 30 and 10. There is no changes will happen because 80 is greater than 40 and 80 is greater than 30, 80 is greater than 30. So your sorted elements will look like this: 10, 30, 40, 70 and 80. This is in a sorted order. This is called insertion sort. Very simple concept. You just take one unsorted list of elements and compare each and every element with single elements and swap the elements. according to the position of the element, you just swap the elements. First I have swapped these two elements called 70 and 30. 30 is less than 70. Then, so I can change the first iteration like 30, 70, 40, 10 and 80. And in a second iteration, I have compared this 70 with 40. 70 with 40 means 70 is higher than the 40. So, you can swap these two elements 30, 40, 70, 10 and 80. And again in the next iteration, you just compare these two elements 30 with 40. So, these two are sorted elements and these are unsorted element. So, again you just compare these two elements called 30 and 40. Is there any changes? No changes happened. So, you can write this 30, 40, 70, 10 and 80. And again in the next iteration, I will compare this 70 with 10. So, 70 is higher than 10. So, we can swap these two elements, 10 will come this side and 70 will go to the fourth position. So, here again you need to compare these two values, that is 40 with 10. So, 10 is less than 40. So, you can swap it again, you will get 30, 10, 40, 70 and 80. And again after this, compare these two elements, that is 30 with 10. So, 10 is less than 30. So, again swap these two elements, that is 10, 30, 40, 70 and 80. So, these are in sorted list, these two are in unsorted list. So, again you just compare these two elements called 70 with 80. You just check the values. So, 80 is greater than 70. So, there is no swapping. Again you just compare this 80 with any other elements. So, there is no swapping because 80 is greater than all these elements. Your array will look like 10, 30, 40, 70 and 80. This is in a sorted order. Very simple concept. You just take the unsorted list and arrange it in a sorted order. This is called as insertion sort. Let me check with the algorithm. A is an array with unsorted elements, n is an unsorted elements. For I is equal to 1 to n minus 1. Why it is 1 to n minus 1? Because here we are always assuming the index values from 0 to n minus 1, right? But here I will consider the first position as a key element. I will use the for loop for I is equal to 1 to n minus 1. Instead of taking 0 to n minus 1, I will assume, so I is equal to 1 to n minus 1. And also I will take one variable called j. The I value I will copy to the j value. So, I is equal to 1, we can assume j is equal to 1. And while loop, I will start with a while loop. J is greater than or equal to 1. Greater than or equal to 1 means, so j value is greater than or equal to 1. You start from the while loop, and if condition is a of j is less than a of j minus 1, if a of j is less than a of j minus 1, so if your key value is less than the previous value, so you can use the method a of j is less than a of j minus 1, and temp is equal to a of j. I will give, so here I will take the temporary value is equal to a of j. I will take the temporary value is equal to a of j, and a of j is equal to a of j minus 1. You just check the previous values and compared with each values. So, you have to use the temporary value called a of j, and a of j minus 1 is equal to your temporary value means end of the loop, and again j is equal to j minus 1. J is equal to j minus 1 means, so here j is equal to j minus 1 means here the first element is a of 0, that is 70, and the second element is a of 1, that is 30. So, 30 is less than 70. So, here 30 will go to the first position and 70 will come to the next position. So, a of 1 will reduce to 0 and A of 0 is increased to A of 1. So, here J is equal to J minus 1. A of 1 is reduced as 0 position. So, J is equal to J minus 1, end of while loop, end of for loop and exit. With this, we have end of the operations on one dimensional array. So, one dimensional array means it consists of only subscript value. It can be row or can be column. So, in one dimensional array, we have studied so many operations, that is traversing, insertion, deletion, searching, sorting. So, these are the important operations performed in one dimensional array. And next we have two dimensional array. So, what do you mean by two dimensional array? A two dimensional array is a collection of elements. Of each element is identified by pair of subscript. Each element is identified by pair of subscript. Example, have taken A of 5 and 5. Here this we can consider it is row and this is column. So, two dimensional array is a collection of elements. Of each element is identified by a pair of subscript. In one dimensional array, it consists of only one subscript. In two dimensional array, it consists of a pair of subscript or index value. It consists of pair of subscript or index value. We can tell it is a two dimensional array. And the elements are sorted in contiguous memory. The elements of two dimensional array we can call it as rows and columns, and the number of rows and columns in a matrix is called as order of the matrix, and it is denoted by m cross n. Example, 2 cross 2, 3 cross 3, 4 cross 4, etc. The order of the matrix is denoted by m cross n, and the number of elements can be obtained by multiplying number of rows and number of columns. So, the order of matrix is obtained by to multiplying the number of rows and the number of columns. Example, this is one example for order of matrix. This is called as 3 cross 3 matrix. Why it is 3 cross 3 matrix? Because we have 3 rows and 3 columns. We can call it as a 3 cross 3 matrix. The order of the matrix is considered as to multiplying the rows and columns. This is one example for 3 cross 3 matrix. Why it is 3 cross 3? We will get 3 columns and 3 rows in 3 cross 3 matrix, and it is denoted as m cross n matrix. So, m cross n means value of m is 3 and value of n is 3. This is 3 cross 3 matrix. How to represent the order of the matrix? So, the columns are called as 0th column, first column, second column, and the rows are A of 0, A of 1 and A of 2. Here we have 3 rows and 3 columns. This is called as 3 cross 3 matrix. So, the two dimensional array is a collection of elements, and each element is identified by pair of subscripts. Pair of subscripts or pair of index, we can call it as a two dimensional array. Next we have the representation of two dimensional array. Already I have discussed the order of the matrix is denoted by m cross n. We need m cross n memory locations. So, we need m cross n memory locations. The elements should be in contiguous memory locations. If you want to add m cross n matrix, so we need m cross n memory locations. And we have two methods for representing the two dimensional array, that is row major method and column major method. So, what do you mean by row major method? Row major method. Example, consider the array in A of 3 and 3. So, row also 3 and column also 3. This is 3 cross 3 matrix. And the 9 elements are stored in the contiguous memory locations. 3 cross 3 means how many locations we need? 9 locations. 3 cross 3 means required 9 elements are stored in the contiguous memory locations. So, how to represent the row major order? Here I have taken some number of elements, that is in the form of 3 cross 3 matrix, 3 columns and 3 rows, that is A of 0, A of 1, A of 2, 0, 1 and 2. Here we have 9 elements. Here I assumed 9 elements, that is 3 cross 3 matrix. In 3 cross 3 matrix, how to represent in a row major order? I will show you how to represent in a row major order. First, I will assume A of 0. A means is a name of the array. A of 0 and A of 0 column. A of 0th row and A of 0th column, that is A of 0 into 0. So, A of 0th row and this is column. A of 0th and 0 and A of 0, A of 1, that is A of 0 into 1, that is row and column. A of 0 into 1 and A of 0 into 2. A of 0 is row and column is 2, second column. So, A of 0 into 0 means the value is 2 and A of 0 into 1 is the row value is minus 2 and A of 0 into 2 is row value is 3. So, my value is 2 minus 2, 3. This is in a row order. And in a second row, I will assume A of 1 and A of 0. A of 1 into A of 0, that is A of 1 into 0, this is row and this is column. And A of 1 into 1, this is row, this is column. A of 1 into 1 and A of 1 into 2. So, the value will be 1, 0, minus 3. 1, 0 and minus 3. And in third row, we have A of 2 into 0, that is row and column. A of 2 into 1, row and column. A of 2 into 2, row and column. The value will be 2, 2 and 5. 2, 2 and 5. This is in a row major order. And what is this 2001, 2002, 3, 4, 5, 6, 7, 8, 9? These are called as base address. These are the base address in memory location. So, 2001 for first order, 202 for second row, 3 for third row, 4, 5, 6, 7, 8 and 9. These are the base address in a memory location. Now, using this formula, we have one formula for finding the row major order. Here we can find the memory location, memory address of the element. So, easily we can find the memory address of this location A of 1 and 2. We will find the location of 1 and 2. LOC A of I means it is row, that is 1. J means I will consider it is 2. Here I need to find the location of the memory address location of the element A of 1 and 2 is equal to, so what is the base address? We have starts from 2001, that is our base address 2001 and plus what is the value of W? Value of W. So, what do you mean by W? W means width of the each memory location. This is called as starting address. 2001 is my starting address. So, width of the memory address is 1. 2001 is my starting address. So, we can observe these two address. So, what is the width of this two address? 1 is the width of these two address, and you can observe this second and third address. So, width of the address is 1 and third and fourth width is 1, fifth and sixth width is 1, 7 and 8 width value is 1, 8 and 9 width value is 1. So, W is equal to, I can write this 1. And what is N and M? N and M means this is the order of the matrix M cross N. 3 cross 3 matrix. So, M is equal to 3 and N is also 3. M cross 3 means it is 3 cross 3. M cross N means 3 cross 3. M value also 3, N value also 3. 3 into I. I value have taken 1 minus. So what do you mean by LB? LB means it is a lower bound. Lower bound starts from 0. So LB value is 0 plus what is the value of J? 2 minus 0. LB value is 0. Find the address of the memory location 1 and 2 plus 1 into 3 into 1 minus 0. 1 minus 0 is 1. 3 into 1 is 3 plus 2 minus 0. 2 minus 0 is 2. 2 0 0 1 plus 3 plus 2 is 5. 2 0 0 6 is my address of this memory location A of 1 and 2. So address of this memory location is 2006. This is the representation of row major order. Very simple concept. Next is column major order. Here we have 3 cross 3 matrix, that is M cross N order. All the first column elements are stored in sequential manner. First column elements are stored in sequential manner. This is 3 cross 3 matrix. So 3 cross 3 means M value also 3, N value also 3. Here we have A of 0, 1, 2. 0, 1, 2. This is 3 cross 3 matrix. So here again I will consider 2, 0, 0, 1 and 2, 0, 0, 2, 3, 4, 5, 6, 7, 8, 9. The starting address is, base address is 2001. The width of this address is 1. These are the elements are stored in a memory location, that is A of 0, 0. A of 0, 0 means value is 2. Here in column order, these are the elements are stored in a sequential manner. A of 0, 0. Here you need to consider from column to column. A of 0, 0, it is 2. A of 1, 0 is 1. A of 2, 2 is. From column order you need to consider the value A of 0, 0, 2. A of 1, 0, 1. A of 2, 0, 2. So 2, 1, 2 is your first column order. And A of 0 and 1, A of 1, 1, A of 2, 1. That is minus 2, 0 and 2. Minus 2, 0 and 2. In the third column, we have A of 0 and 2, A of 1, 2, A of 2, 2. That is 3, minus 3 and 5. These are the elements stored in a sequential manner in a column major order, and these are the location of these elements. Here I will consider this A of 1 and 1. Here I need to find the memory address of this location A of 1 and 1. A of location is A of 1 and 1. So what is the base address? What is the base address? 2001 plus W value is, width of the element is 1 and I value is 1 minus LB is 0 plus M value is 3 and J value also 1 minus LB value is 0. So find the base address is 2001 plus 1 into 1 minus 0 is 1 plus 3 into 1 is 3, that is 2005 is your base address of A of 1 and 1. Base address is 2005. Very simple. Using the concept of row major and column major order, we can find the representation of two-dimensional array. For column major, you have to use this method, and for row major, you can use this method. This is called row major order and column major order. Next, we will see the applications of an array. Arrays helps to implement all other data structure such as queues, stacks and strings, etc. This array helps to implement other data structures called stacks, queues and strings. So it is very helpful for implementing the other data structure, and it is also used to implement mathematical vectors and matrices. Already we have seen how to implement the row major and column major order, that is with the help of 3 cross 3 matrix, that is M cross N order of matrix we can implement. So it is also used in implement mathematical and vector matrices. And next we have to find the advantages of an array. It is easy to implement multiple data elements and it can hold number of elements. It is a collection of variables and it can hold the number of elements. And it is used to represent multiple data items of same type by using single name. By same type using single name. And it can be used to implement other data structures like linked list, stacks, queues, strings, trees, etc. And two-dimensional arrays are used to represent matrices. For implementing the matrices, we can use this array, that is two-dimensional array. In array, the elements are arranged in a sequential manner, so easily we can access the elements with the help of index values. So, easily access the elements with index numbers and easier to access each element of the index value. It is easier to manipulate and store large data. In array, we can store large amount of data and we can manipulate it easier. And next we have what are the disadvantages of array. Array is a data structure. It means that array is of fixed type. Array is of fixed type, the memory which we are allocating that cannot be increased or decreased. So, array, once you added the value, fixed value, we cannot be increased or decreased. So, this is a main disadvantages of array. And array is fixed size. If we allocate more memory than the requirement, then the memory space will be wasted. And the elements of array are stored in consecutive memory locations. So, insertion, deletion are very difficult to implement. So, insertion and deletion are very difficult because we need extra time for shifting the data. That means, in every time we need extra time for shifting the elements from one place to another. So, insertion and deletion is very difficult to implement in array. So, these are the disadvantages of array. So, array is a data structure. It means array is a fixed size. We cannot increase or decrease the value of array. In my next session, I will come with a new topic called stacks. Thank you.